Hello my dear student, myself SANJAY SHARMA from Rishil Vidyapith Sonipat. I am here for class 11 module 1 of chapter Motion in a Plane. Here in this chapter we have to discuss a very important term, that is what is scalar quantity and what are vector quantity. The students generally have confusion in both. Basically, the scalar quantities are those in which they express completely themselves by their magnitude only. They do not require any direction. Like if I am having this pipe and I am saying the mass of the pipe is, let's say, 50 gram, then you automatically understand the mass of the pipe is 50 gram. I mean, you will not ask, sir, what is the direction of the mass? Because mass is not having any direction. It's complete that the mass of the pipe is 50 gram. This is the scalar quantity. And then, if I am asking, what is the time now? And you are saying, sir, 5 o'clock. Then I automatically understand. 5 o'clock means 5 baj gaye hain bhai. It means no requirement of direction in case of time. So what are these? These are the scalar quantities. So scalar quantities, I am telling you again, the scalar quantities are those, the physical quantity which are completely specified by the magnitude only. These are called as scalar quantity. And the examples of scalar quantities are length, mass, time, volume, density, temperature, work, energy, and many more. One special scalar quantity I have not written here because I will discuss one example with you related with that. I think you understand about scalar quantity. Next one is we have to know about vectors. So what are vectors? So vector again, first you see the definition, then I will tell you again. The physical quantities which have both magnitude and direction and also obey vector laws of addition are called vectors. Generally the students say that the vector quantities are those only, those they have magnitude as well as direction. But they don't think about vector laws. Or you can say vector laws of addition. So when you are not considering the vector laws of addition, then we cannot say completely that this quantity is vector or not. So it is very, very, very important to know vector, that vector, it have to obey laws of vector addition. To try to see, if I am saying, try to understand what I am going to tell you. If I am telling you that a length L is equal to 5 meter. Simply, I have to make a 5 meter line. Or, I have to make a 5 meter line like this also. Both are of 5 meter. Both are of 5 meter. So, these are what? 5 meter length. So, this is scalar quantity. But, if I am saying the 5 meter line toward east, so, try to see. We all know that how we make the direction, how we understand the direction. We write generally east, west, north, south. If I am starting from east to this situation, and this is what? 5 meter. But because according to the question was 5 meter toward east. So, I have to make arrow here because it will give us the direction. What? It will give us the direction. And this direction is toward east, having direction as well as magnitude. So, in this condition, this is what? A vector quantity. But now this is not length. This is called here, we can say, displacement. This is called as displacement. So in this condition, if I am saying that a person is covering displacement L equals to 5 meter toward east. So 5 meter is the magnitude and east is the direction. So direction as well as magnitude specify what? Vector quantity. So it is the important thing in case of vectors. But here I have not discussed the laws of vector addition, because here we have not used the laws of vector addition. So it is the additional quantity which is required sometimes. So here I think you can understand one more thing. As I have not written one important example here that I am discussing now, and that is here current. So the question arises, if this is current and the current is flowing A to B and this is of 4 ampere. The current is flowing of 4 ampere from A to B. If the current is flowing from A to B 4 ampere, then according to the maximum student, the current having direction, which we have shown with the help of arrow, and another one is magnitude. So it should be a vector quantity, but if 4 ampere current is coming from here, let's say C to A, and this is B to A, 2 ampere current is passing here, and current, how much current is passing here? 4 ampere plus 2 ampere, simply it is 6 ampere. So what we have done? Simply the algebraic sum. We have not taken into account this angle. But if this was you can say it was a vector quantity, if it is a vector quantity, then the angle plays a very important role. I am giving you one more example at the same time. This was the example of electric current. This was the example of electric current. If let's say we are saying 4 Newton force, let's say F1 is the force, 4 Newton force acting in this direction, and another maybe let's say same I am taking maybe 2 Newton force acting in this direction, and the resultant force will be here. So can we write directly the net force equals to 4 plus 2 equals to 6 Newton? No, it is wrong in case of force. So in this condition we cannot say the net force is equal to 6 Newton, because this is not the algebraic sum. So in this condition, the angle plays a very important role. If we change the value of the angle here, there will be no change in the value of current. But if you will change the value of angle here, it will change the value of resultant force. It means in case of vector quantity, no doubt magnitude as well as directions are very important, but the laws of vector addition also plays a very important role, and this angle is very important part of the vector addition. So I think you understand now what is that. Vectors are those quantities, you can say those physical quantities which have both magnitude and direction and also obey vector laws of addition, and these quantities are known as vectors. इनको हम vector कहते हैं बेटा. So these are vector quantities. So I think you understand about vector and scalar. Okay. After vector and scalar, we have to see how can we represent vector quantity. How can we represent this vector quantity? See, representation of vector. Let's say, as I already discussed one point A to B, and this was, let's say, 5 meter length, or a person is covering 5 meter distance, but I have not giving you hint in which direction the person is moving, in which direction the particle is moving. So you can draw A to B or you can draw B to A, because from both sides it is 5 meter. But if I am saying a person is moving from A toward east, as I told you how we show the direction. This is what? E. East, west, north and south. These are the indication of the direction which we use generally. So if I am saying a person is moving 5 meter toward east, so in this condition I have to show just like this A, B vector, and it is equal to 5 meter, and that is toward east. And here I think you understand 5 meter is representing magnitude and toward east is representing direction. So this is the representation of vector quantity. Here this is the sign which converted AB as in a vector quantity. But if in another condition a person is moving from its position B toward west, if it is moving from B toward west, then how can we show its vector condition? 5 meter toward, we can say, toward west. So how can we show it? Simply we can show B, a vector quantity, is equal to 5 meter toward west. But according to some students, what they think about, sir, A and B are same. Only what the changes? Only a change of arrow. So why you have written here AB vector and this like this? Can we write in this manner? So beta, it is not the symbol of vector. Always, whenever you want to show the vector quantity, you have to show like maybe A to B from left to right, or maybe B to A but from left to right. It is impossible that you can show just like this. It is wrong. It is wrong practice. So you cannot show the just like. But if you want to write your answer in this form, then we can write BA equals to AB but with minus sign. And what is the significance of minus sign here? The minus sign shows simply the opposite direction. The minus sign shows opposite direction. This is simply the opposite direction. So minus sign shows a very important role if you want to show your B to A vector in the form of A to B vector. This is the representation of a vector quantity. I think you understand. If you understand, then I will come on my small another topic, that is what? Position vector. Simply, which shows your position from the origin, that will give you the position vector. How can we show with the help of diagram? See on the board. See on the board, beta. How can we show the direction of a position vector? Let's say we have a frame of reference. You have understand the frame of reference in third chapter, that is motion in straight line, and then we have considered it is our origin, and a moving particle at any situation, at any condition, maybe at point A. If it is at point A, so to understand its exact positions with respect to origin, we have to make a straight line. and because we have to know the exact position, so we know its direction also. And this will give us the exact position, and that is called as position vector of this particle A. Or you can say the particle is P. So the particle P is present at A position. So R1 vector gives the position of the particle P at A position. So this is called as position vector. See the definition? A vector drawn from the origin to the position of a particle at any instant is called position vector. From origin, whatever the new position of a particle is there, if we draw a line with its direction, that will give you the direction as well as magnitude, and it shows its position. So this is a vector quantity, so it is a position vector. But if our particle P is in motion and it comes up to B, the new position of our particle P is B position. So now what is the new position vector of our P particle when it reaches at B point? What is that? Simply, we have to make a straight line from the origin, and that arrow with direction and magnitude gives you the position vector. So here R2 cap is representing the another, or you can say new position of the particle P at point B. But one more term you can see, displacement vector. So you can understand about, initially the particle was at A position, and anyhow because of it was in motion, so it comes up to B position. So now this arrow with direction, you can say with magnitude and direction, it is shown here its magnitude with direction, which is representing as displacement vector. So it is here a B vector. So here displacement vector is AB and position vector is R1 and position vector is R2. So these are the position vector. Which one? R1 and R2, and AB vector is representing the displacement vector. Displacement means in which vector we are showing the displacement position of the particle, and R1 and R2 are showing as a position vector because these are representing the exact position of the particle here. Now in another topic, we have to come on types of vectors. So how many types of vectors are there? Basically, vectors are of two types. The first one is polar vector and another one is axial vector. So first of all, we have to know what are polar vector and what are axial vector. For that, you just see the definition of polar vector is a polar vector quantity whose direction is along the direction of motion of the body or a particle is known as polar vector. Mean, if we want to show a vector and the direction of that vector is also in the direction of the motion of the object is there, so that is called as polar vector. Like the example, displacement, velocity, force, these all are the polar vectors. So I think maybe you have a little bit confusion that how these are the polar vectors to try to see. If I am having this object and I am saying apply 10 Newton force on it. If I am saying simply 10 Newton force on it, because if I am saying to you that apply 10 Newton force on it, it means it is my desire, I want to displace this object from one position to another position. See, if I want that this object should move from A to B, and I don't think about that you are a new student and you don't know about the vector quantity, and simply when I am saying apply 10 Newton force on it, then you can apply force just like this, or just like this, or just like this, or just like this. So just consider, if the object is here and you are applying force in this direction, so this object will displace up to here. This is the direction of force, and due to which it can move from A to B. But if you don't understand properly, then what you can do in this manner also. Let's say the object was at A position and I require that object should be reached at B position. But you apply force in this direction. So in this condition, when you apply force, same 10 Newton, and force is a vector quantity. But to understand about the direction, you can say the polar vector, it is an example of polar vector. Just see, when you apply 10 Newton force here, then object will move here, it will reach up to C position. So it is the direction of motion of the object, and the same is the direction of the applied force. So that's why we can say that force is a polar vector. Or you can see, if I am having object here, I want that object should move from A to B, and you are applying force 10 Newton in upward direction, and the object reaches up to this position. If the object is reaching from A to B position, what is this? You have applied force in this direction, 10 Newton, and the motion is also in the same direction, and that's why we can say that force is a polar vector. So in this condition, if we want to move our object from A to B, then I have to tell you that apply 10 Newton force on this object toward east. Then you automatically understand that in which direction you have to apply the force, due to which the object will start to move from A and it will reaches, or it can be, you can say it can reach up to B position. So I think you understand two things. With the help of this example, I discussed two things. The first is why we are saying the force is a vector quantity, and second one is why the force is a polar vector. So again, see the definition. A vector quantity whose direction is along the direction of motion. Whose direction is along the direction of motion. Whose direction is along the direction of motion. That is called as polar vector. But another one is axial vector. Axial vector is just different than the polar vector. It is a vector quantity whose direction is along the axis of rotation of the body or a particle is called as axial vector. It is not easy to understand if you are just reading the definition from the board. So try to understand what I am going to tell you. If we want to rotate and screw, if we want to rotate any screw, then let's say it is its left arm, it is its right arm, and we are rotating left arm towards right arm just like this. We are rotating in this manner. We are rotating in this manner. Then you can understand easily in which direction the screw will move. See, if this is a screw and I am rotating this screw from left to right, mean in a clockwise direction. If I am rotating it in clockwise direction, it is moving in upward direction. And this is what? Its axis. So in this condition, this is the direction of the axial vector. So this is their axial vector. And basically, it is the direction of torque. It is the direction of torque. So torque is the axial vector. Mean the left and right arm are in circular motion. You can say they are having some angular velocity. They are rotating like this. but the direction of the vector is upward direction. So what is it? We are revolving one position towards another position just like this clockwise direction, and it is moving in upward direction. So that's why here this is called as axial vector, because the direction of the rotation of these two left and right arm is in the upward direction. So that's why it is called as axial vector. And the example of axial vector are torque, angular momentum, angular velocity, angular acceleration. Basically, where the angular motion takes place, any kind of, that gives us the direction of the third vector, which is called as axial vector. This was all about related with this module.